Okay, welcome to our lesson on the Cartesian equation of a line in R2. So, you might be thinking, okay, another equation of a line in R2. I already know slope y-intercept, I just learned vector, I just learned parametric, I just learned symmetric, so that's 4, and then we already had standard also. So I already had these. Alright, now I have 5 forms. Do I really have to learn another one? Good news, no. Cartesian equation of a line is really just another name for the standard form. So this form ax plus by plus c equals 0 is also known as Cartesian equation. Did I have just one s? Cartesian equation, or sometimes we'll even give it another name. It'll be called the or scalar equation. So these three names really, all mean the same thing. Scalar equation. Okay, so we're not really learning anything. We're not learning a new form. We are going to learn some new stuff. We're going to really look at how this form relates to the other forms that we just learned, particularly the vector equation. Okay, so what we'll do first is just compare, well, two other forms. So let's first look at, suppose you had a line, and I'll give it to you in y equals mx plus b form. Say y equals mx, let's just say mx plus b, where m is equal to, let's give it some letters, let's call it p over q. So that gives you your rise over your run. Then the direction vector, well, what's the direction vector going to be? Let's just draw it quickly. Okay, so the direction vector is going to be centered at the origin, start at the origin, and it's going to need to follow this direction of the slope. So the rise will be p, I'm going to go up p many units, and I'm going to run q many units. So it's going to be at this point right here, it's going to be like that. So this is the direction vector line. Well, what are the coordinates of that? Q, P. Okay, so that's how you connect the slope to the direction vector. It's just the rise is your y coordinate, and the run is your x coordinate. Very simple. You might have even recognized that from the last unit. That might have just been a quick review. So, for example, let's say y equals 2 over 3x plus 1. Then what's the vector equation going to be? Well, m, the direction vector is going to be, we just said the y, or sorry, the x, the run is our x, so 3, and the rise is our y, so 2. So that's the direction vector. 2 over 3 becomes the direction vector of 3, 2. And then what point? And use point. So we need a point for the vector equation. So which point should we use? Well, what does that tell me? That's the y-intercept. What are the coordinates of the y-intercept? 0, whatever this is, so 0, 1. So therefore r, or the vector equation, is 0, 1 plus t times 3, 2, where t is a real number. So that this example just connects the so y equals mx plus b form to the vector equation. Very good, very easy. So this was the vector equation. Right here. Well, what if we wanted the Cartesian, or we used to call the standard form, now we're going to call the Cartesian equation. So just take this thing, y equals 2 over 3x plus 1. Then how do I get that into standard form, or the Cartesian equation? Well, if you remember, you need to first get rid of all the denominators, or all fractions. So what we'll do is we'll multiply all sides by 3, or multiply each term by 3. So I just multiplied each term by 3, both sides of the equation, so that's allowed. So now I've got, oops, that's an x plus 3. And then I'll isolate, or get 0 on one side. So we'll just subtract 3y from both sides. Okay, so this is the Cartesian equation. Right here really is the Cartesian equation. And up here is the vector equation. So now what I'm going to do is see if I can recognize a sort of connection between these two vectors. And what you might be able to recognize is, look at this. This is a direction vector, 3, 2. And look at the coefficients here. A was equal to 2, and B was equal to -3. And up here, M was 3, 2. Do we notice a connection between these? Maybe, right? 2, 2, 3, -3. So maybe they look perpendicular, you might say, if you were to write this as a vector. So will that always happen? Well, let's check. So let's consider a line with the direction vector, a line, oops, with M, so our direction vector of, and I will just give this letters, so we'll call it AB, passing through point, call this x1, y1. So that's the point. So therefore we know the vector equation is x1, y1 plus t a, b, where t is a real number. That's your vector equation. Well, what about, I don't know, slope? What's this? How about the slope? What's m? Not m vector, but m the slope. Remember that you could connect the direction vector to the slope. It was just equal to b over a. Talked about that. So this is the slope. Well, now let's say I want to get this into standard form. All you have to do that is say m is equal to y minus y1 over x minus x1. Right? This is just a slope form, or equation with slope. And what is m? M we just said is equal to b over a. So y minus y1 over x minus x1. And now to get this into the Cartesian or standard form, just cross multiply. Bad word, but just cross multiply. So b times x minus x1 there we go, and then we'll just expand, and now all we're doing is isolating for 0 on one side of the equation. So I'm just distributive property, now we just need 0 on one side, and we want the x term to be positive. So b times x minus, so I'll subtract ay from this side and this side, and now I'll group these two. Equals 0. Okay, so notice this is the coefficient in front of x, this is the coefficient in front of y, and this thing right here, so this is a, this is b, and this thing right here is c. Very good. So now consider this vector right here, b minus a. Consider a vector. little b minus a. Well, what do we notice? That, remember, the direction vector, we'll call m, maybe I'll just write that, we'll call our direction vector was equal to AB. What do we notice about these two vectors? I think we made a conjecture earlier, or a guess, that these two vectors would be perpendicular. Well, how can I check if they're perpendicular? A dot B, or AB dot B minus A, that's equal to A times B plus negative A times B, which is AB minus AB, which is 0. Therefore, the vectors are perpendicular. So this tells us how to get those two coefficients. It's just the perpendicular vector to the direction vector. Okay, and we give this a special name. So a vector perpendicular to a line is called its normal vector. You might have heard that when we did calculus. Okay, so parallel to the line, direction vector, perpendicular to the line, normal vector. Okay. So now the Cartesian equation we know is ax plus by plus c equals 0, but now we know where to get this a and b from, right? Where a and b, where vector, and we'll call this n, we'll use an n equals big A, b is normal vector, is a normal vector to the line. Okay, so very nice. It gives us a very simple way to do this. So just look at a quick example and you'll see how fast we can find the Cartesian equation now. So we want to find the Cartesian equation of this line, where this is the vector equation. Okay, so all we need to do, m, the direction vector, is 2, 3. So we just need a normal vector to this. Well, we've seen how to do that already, right? We know how to figure out a perpendicular vector. All you do is switch x and y and make one of them negative. It's up to you. So this is my normal vector. So we know the Cartesian equation looks like this: ax plus by plus c equals 0. And we said earlier that this is a and this is b. So negative 3x plus 2y plus, now this I don't know, c equals 0. Now how do you get c? Well, we know an x and a y, so just use, so sub in 0.12. So if we do that, and now we have an equation where c is the only variable or unknown, so we can solve for c. 1 plus c equals 0, so c is equal to negative 1. Therefore, the equation is what would this be now? Negative 3x plus 2y plus c, which is negative 1, is equal to 0. So that's your Cartesian or scalar equation. And you might notice a lot of times we don't want the negative in front of the x, so what we'll do is just move everything to the, or subtract everything from that side and get it onto the other side. So 3x minus 2y plus 1 equals 0. So that's actually a better answer. Okay, so that's the Cartesian or scalar equation of a line.